Hi, and in this video, we are going to go over your Unit 2 test review. All right, so here's question 1. What is the expression in radical form? So to do this, you're going to distribute that 3/4 in the fraction to every one of those fractions. So that means you're going to have 4 to the 3/4, you're going to have x to the third times 3/4, and so on. So simplify that, and you're going to end up with 4 raised to the 3/4. And then notice that all of your all the denominators are all 4. Okay, so that means you're taking the 4th root. So after you simplify that, your answer is going to be this right here. The 4th root of 64, x to the 9th and y to the 6th. All right, so now what is the expression in simplest radical form? So if we have the square root of 675, so the square root of 675, we need to think about the perfect square. What is the largest perfect square that goes into 675? Well, the largest perfect square that goes into 675, now you can break it up because I know this is a large number, okay? So if you want to break this up and use the factoring tree, it's over here on the right. All right, it's over here on the right. But I know that the largest perfect square that goes in there is going to be 15 squared. And that's 225. So 675 divided by 225 gives me 3. So watch what happens. I get the square root of 225 times 3. So the square root of 225 is 15, and then you leave the 3 underneath the square root. Okay? So this would be your answer, 15 on the square root of 3. You get the same answer either way. So I know this is a large number, so if you want to use the tree, that is perfectly fine, or you can use this. I like to show you both. Okay, so you get to decide which way you want to simplify your radicals. All right, so let's look at question 3. We're going to find the third root of 216 times x to the 18th, y to the 30th. So we're going to find the third root of 216. So what can you multiply by itself 3 times to get 216? So all you got to do is type that in your calculator. The third root of 216 is 6. All right, now we're going to talk about your variables because the 216 completely cancel to a 6. Third root of 216 is 6. Now, third root of x to the 18th. So you're going to ask yourself, how many groups of 3 do you have in x to the 18th? So basically, does 3 go into 18? And the answer is yes. It goes in there 6 times, right? Now let's talk about the y. So does 3 go into 30? Yeah. Notice there's nothing left over. Now if you had y to say the 31st, if you had y to the 31st underneath there, then you would have a y left over. So in this case, you don't have anything left over, and your answer is just 6. X to the 6th, y to the 10th. Okay, if you had anything left over, it would be underneath the square root. All right, so let's look at question 4. Assume x and y are non-negative. So we're taking the square root. So we have 4 on the outside with the square root of 72. So what is, here we go, I'm going to leave a little space right there for my x's and my y's. So what perfect square goes into 72? So we need to think about our perfect squares. Remember, your perfect squares would be like 1, 4, 9, 16, 25, 36, and so on. Perfect squares. So let's figure out what perfect square goes into 72. Well, Well, 72 is made up of 36 times 2. Now, 36 is a perfect square. Keep that in mind. 36 is one of those perfect squared numbers I just listed out. So we'll simplify him in just a minute. Now let's look at x to the 24th. So x to the 24th, so square root of x to the 24th. We need to figure out how many pairs of 2 x's do we have in 24 x's. Oh, that's 12. So that means x to the 12th comes out. Same question with the y's. How many pairs of y's do you have in y to the 13th? Well, you have 6 with 1 y left over. Okay, and if you want to see that listed out, it is listed out over here on the right. Okay, this is the tree, the factoring tree listed out. I like to show you both ways to simplify. Now, let's simplify that 36. So I'm going to bring this down. So 4, x to the 12th, y to the 6th. Then this square root of 36 is a 6. And then my 2y is left underneath the radical. So now all we have to do is multiply 4 times 6. So we get 24 x to the 12th, y to the 6th, on the square root of 2y. Okay, so if in the OHS you have to list this out, be very, very careful with your exponents and make sure you type it in exactly the way it should be typed in. Okay? Alright, so let's go through this one. We are simplifying. So we have 6 on the square root of 27 minus 5 on the square root of 48. So again, if you want to use the factor trees, it's over here on the right. So I'm going to figure out what perfect square goes into each one of these. So I have 6 square root, now 27. What perfect square goes into 27? Well, that is 9 times 3. For the perfect square is 9. Now, what perfect square goes into 48? Well, the perfect square that goes into 48 is 16. That is 16 times 3. So let's simplify these. So I have 6 times square root of 9. That's 3. Then you're left with that 3 on the inside. Minus 5 times square root of 16. That is 4. Times that 3 stays on the inside of the square root. So simplify again. 6 times 3 gives you 18 on the square root of 3. Minus 5 times 4, that's 20 on the square root of 3. Now, anytime you are adding or subtracting these radical numbers, it's just like you're adding or subtracting variables. You have to have the same thing. You have to have the same number underneath the square root. You have to have the same index. So they're both square roots, and both of them have a 3 underneath. So we can combine them. 18 minus 20 gives me a negative 2. Then write your square root of 3. Okay? All right, now we are multiplying. We are multiplying each one of these. So if we just multiply, so this is for question 6 and 11. So if we just multiply out the 13 times 5 times 3, you're going to get the square root of 195. Now notice that the 13, 5, and 3 are all prime numbers. So since they're all prime numbers, you can't simplify this anymore. Alright, so here's one just like question number 7. We're getting into the whole complex numbers now. So we have a square root of a negative number. We need to bring that I out. And notice that I have if you want to use the factoring trees, I have it over here. So I have 3 on the square root of 75. Now, you have to bring out that I. So you bring out the I and you put it with the 3. Now we have to figure out what perfect square goes into 75. So the perfect square that goes into 75 is 25. And 25 times 3 gives you 75. So, square root of 25 is 5. So I have 5 times that 3i, and then the 3 stays on the inside. So on the outside, we have 5 times 3, that is 15i on the square root of 3. Okay, so if you have any questions, let me know. All right, question 8. So I would keep a note of I through I to the 4th. Okay, I would keep an I on the, or just write it down. Just write this whole table down if you want to. So first I would do, take 87, divided by 4. Notice you get 21.75. So figure out what 4 times 21 is. So that's I to the 4th times 21. So that is so that gives you that 84. So this is the same thing as I to the 84 times I to the 3rd. I'm just trying to explain this a couple different ways. So I to the 84th times I to the 3rd gives you that 87. So 84 plus 3 gives you 87. Now, this is written the same way as I to the 4th raised to the 21st. Then you're left with I to the 3rd. Now, I to the 4th. Okay, I to the 4th is equal to 1. So that is just like I replaced that with a 1. So that is 1 to the 21st, and 1 raised to any power. 1 raised to any power is 1. And 1, all this whole thing right here is just equal to 1. Whole thing is equal to 1. And then I'm left with just I to the 3rd. And what did we say I to the 3rd is equal to? That is equal to negative I. So therefore, I to the 3rd is equal to negative I. And that's how we get the answer, negative 1. Or negative I. So this question is just like question 9 and 11. So we have negative 4i on the square root of negative 48. And again, if you would like the factor tree method, it's over here on the right. So I have negative 4i. Now we have to bring out another I. Then we have positive 48 because you can't take a square root of a negative number, so we have to bring out the I. So notice what we have here. Negative 4 times I squared on the square root of 48. Now, I squared, not cubed, I squared is equal to negative 1. Always remember that I squared is equal to negative 1. So that means I have negative 4 times negative 1. Now what perfect square goes into 48? Well, that's 16 times 3. Alright, so let's simplify this. Negative 4 times negative 1 gives me a positive 4. Now the square root of 16 is 4. Then we're left with square root of 3. So on the outside we have 4 times 4, so that gives me my 16 on the square root of 3. So 16 on the square root of 3. Okay? Alright, so we are simplifying, and you can see it is written out over here for you. But if you would like, I can go through it again. So we have 4 times 3, that gives you the 12. Then we have 4 times 6i, that gives you plus 24i. And then we have negative 5i times 3, so that's a negative 15i. And then I have negative 5i times 6i, so that's a negative 30i squared. Combine like terms, so 24i minus 15i gives you a 9i. So let's write down what we have. Now, this I squared, remember, I squared is equal to negative 1. That's the whole magic between all this. I squared is equal to negative 1. You have to know that. So we replace the I squared with the negative 1. This becomes a plus 30. And then add the 30 to the 12, and you end up with 42 plus 9i as your answer. So that is a 42 plus 9i. All right, so on this is just like question number 12. And again, you have to distribute. I have it written over here where you would use the factoring trees if you want to use that. So first distribute, so we get square root of 48 plus the square root of 40. So simplify. So first you need to figure out what is the perfect square that goes into 48. Well, that is 16 times 3. And then over here, we have square root of 40. So what perfect square goes into 40? Well, that is 4 times 10. So square root of 16 is 4 on the square root of 3 plus, take the square root of 4, so that is a 2, and then leave your 10 underneath the square root. Notice that you cannot simplify anymore because the square root of 3 and square root of 10 are different. If they were same, then you could simplify them and combine them together. But they are two totally different square root numbers, so you have to leave them separately. All right, so for this lesson, you have the Cycle 1 Week 4 Take It Out the Door complex numbers. I still want you to go through this lesson and take your practice problems. You still need to go through and take the practice test. You will find that in the OHS, and those same questions are also on this Microsoft form where you watch this video. Okay, so please make sure you work through that. But your password is cycle, is number 2, cycle 2. Okay, so it's 2, cycle 2, all lowercase letters right here. But again, make sure you take your practice test and make sure you complete this and watch the practice test video before you take your Unit 2 test.